In this lesson, we're going to be covering slope, y-intercept, and x-intercept. If you're not confident in any of these three topics, I'd suggest you watch this video. Otherwise, you can feel free to skip this. Slope, y-intercept, and x-intercept. But first, let's review the content of the previous video quickly, which was about linear functions. Linear functions are functions that have a constant rate of change and they can be written in this form. F of x is equal to a rate of change multiplied by x plus some initial value. And quickly here, I just want to review some function notation. So if you have a function f of x, this f here is just simply the name of the function. And that name can be anything you'd like. It could be G, it could be H, it could be Apple, it could be whatever's meaningful, whatever is a meaningful name for whatever that function does. And in this case, the name of that function is f. And say that you have a function f of x is equal to y. F is going to relate the input, which is x, to the output, which is y. That is what a function does. It maps the input x to a y. So let me go ahead and write that also. X is the input and y is the output. Okay, so I'll box that off and let's get back to linear functions. So we'd kind of learned about this. We had learned that a linear function is, going to be some value is equal to a rate of change times x plus an initial value. But we learned about it in a slightly different way. We learned about it in this written something like this. Y is equal to w times x plus b. And it turns out that this way of writing a linear equation, basically an equation for a linear function, this is something called slope-intercept form. So slope-intercept form is a way to write linear equations in the form y is equal to wx plus b, where w is the slope and b is the y value of the y-intercept. Okay, so the takeaways here are that this form of writing a linear equation, which is an equation of a linear function, this way of writing the equation of a linear function is called slope-intercept form. Y is equal to wx plus b. And in slope-intercept form, w is the slope and b is the y value of the y-intercept. So now let's look into more about what these terms mean. What does slope mean? What does y-intercept mean? So we have this linear equation in slope-intercept form, y equals wx plus b. And what the slope is going to be in this is just simply the rate of change of a linear function. And b is going to be the value of the function at 0. When you input 0 into the function, the value that you get out of the function is b. And the y-intercept is a point at which the function intersects with the y-axis. And this is going to happen at the point 0b. This might still be a little bit abstract, so let's look at a more specific kind of concrete example. Say you have the linear function y is equal to negative 0.15x plus 2.7. And say that this linear equation represents how much an icicle is melting per hour. So we could say here y is the height of the icicle, and x is time elapsed in hours. So you could see here that essentially what's going to happen is, as when we start out, time is equal to 0, which cancels out this term, and the starting value is going to be 2.7. When time is equal to 1, which means 1 hour has elapsed, this is going to be equal to negative 0.15 plus 2.7, which is going to be, I think, 2.55. And when this is 2, this is going to be equal to negative 0.3, which means when you add that with 2.7, it's going to be equal to 2.4. So you can see the icicle is slowly melting as the height of the icicle is decreasing with every passing hour. So let's look at some of the terms that we talked about, and let's see if we can identify them here. So first is W, which is equal to the slope. And again, if we recall, a linear equation written in slope-intercept form is y is equal to wx plus b, and w in this case is negative 0.15, so the slope is going to be equal to negative 0.15. And b is, again, the value of the value of the function at 0, which if we plug in 0 into x here, this cancels out, and you're left with y is equal to 2.7. So that's going to equal to 2.7. And the y-intercept is the point 0b. So that one's easy. It's just 0, 2.7. Let's also take a look at a visual example, just because that might help kind of really crystallize these concepts. Say I have a function that looks something like this, and I want to find the slope of this function. When you're given a graph of a linear function, you can find the slope of it using this formula. Slope is equal to y2 minus y1 divided by x2 minus x1 for 2 points on a line x1, y1, and x2, y2. So whenever you have 2 points on a straight line, you can find the slope of that straight line using this formula. So let's go and try it out here. And they can be any 2 points on that line. They could be as far apart as possible or as close as possible. So for this example, let's choose maybe 1, 2 as point 1. So let me write that out here. Point 1 is 1, 2. And let's choose maybe -1, -2 as point 2. So point 2 is equal to -1, -2. And let's plug them into this formula. So the formula is y2 minus y1 divided by x2 minus x1. And that's going to be equal to, so first we look at y2, which is going to be for point 2. And the y value of point 2 is -2. -2 minus 2 divided by -1 minus 1. And again, that this -1 is coming from, we're getting x2 here, and that's the x value of point 2, which is -1. And we subtract that by the x value of point 1, which is x1. And this is going to be equal to -4 divided by -2, which is equal to 2. So the slope of this line is 2. And that makes sense. So what slope is really saying is, what's the difference? How much is the line moving in the direction of the y-axis, up and down, versus how much it moves in terms of the x-axis, how much it moves side to side. And we could see here, whenever the x-axis increases by 1, the value of the y-axis increases by 2. And that's also true here. Whenever x goes from when x goes from -1 to 0 in terms of the x-axis, it goes from -2 to 0 in terms of the y-axis, which is a increase of 2. And that would apply, as far as you want to go. And you could be at the point 1 million, and it's going to, when it goes from 1 million to 1,000,001, it's going to increase by 1 in terms of x, and in terms of y, it's going to increase by 2 for this line. So that's kind of what the slope represents. There are 2 more points I want to quickly cover in this video. The first is x-intercepts. So x-intercepts are the point or points where a function intersects with the x-axis. So just like how the y-intercept is where the function intersects with the y-axis, x-intercepts are the point or points where a function intersects with the x-axis. So here, on this graph of this function, here's the x-axis, and where the function intersects with it is right here. So that's the x-intercept. There's one other pretty critical difference, which is that you probably noticed how for y-intercept, it's just up to 1 point. A function can just have up to 1 y-intercept. It's possible that a function has no y-intercepts if it never intersects with the y-axis, but with the x-intercept, it can have 0 or more x-intercepts. So let's look into why that is. Say this function was not a linear function, and it was some sort of, um, not, it was some sort of nonlinear function, and it looped back like this. And if you looked at it and you looked at the y-axis, you would see it intersects with the y-axis in two places, here and here. So you could say, hey, those are the two y-intercepts. Why can't a function have two y-intercepts? But going back to the first video in which we defined a function, what's really critical about functions is that each x-axis only has one value mapped to it. And here, when x is equal to 0, it would mean that it has two y values mapped to it. So if a function has two y-intercepts, it would not be a function any longer. So that's not possible. However, for x-intercepts, say that, again, this was some sort of nonlinear function and it went down, something like this. And we look at where it intersects with the x-axis, and you can see it intersects it with it here and here. That's totally fine. Again, in that first video, we talked about the vertical line test. Each x value has just one value, one y value that's mapped to it. So that's perfectly legal, and this is still a function. But that's kind of why there can be multiple intercepts that a function has, but only up to one y-intercept. The last topic I want to touch on is something called parameters. So again, say you have the linear equation y equals wx plus b, which is in slope-intercept form. W and b are called parameters for this function. W and b. And these define the shape and position of the linear function. What that means is when you modify W and B, when you change them, you can change them to any value to draw almost any linear function. They are how you kind of change what a linear function looks like. And it turns out that by modifying W and B, you can actually draw every single line you could possibly think of, every single possible straight line you can think of, except a vertical line. So that's something that's going to be kind of important for AI later on, is just to know that these terms W and B are called parameters, and changing them kind of changes what the linear function is going to look like. So that's all for today. Thanks for following along. I also highly encourage you to go to my website, www.learnaimath.com, where I have some problems for each one of these videos. It's great to kind of conceptually go over all these things, but the other half of the work is going to be doing the problems. And that's where you're going to kind of really see, how much do you understand things, and, what else you still have to learn. So I think they'll be helpful for you. And I have tons of free problems on my website. So I'll see you next time.